Sorry, folks, there was some issue with the audio. I guess it got fixed now. So let me just step back a little and walk you through what I have covered so far. Sorry about the audio issue. So there was a problem with my mic and looks like it is now fixed. So this session is very different from some of the other sessions. In fact, this doesn't have many slides. This is the only slide that I'm going to show you. So most of us are familiar with Kubectl, and we use it for dealing with the Kubernetes cluster, Kubernetes deployment, and it is a very powerful tool. But there are some hidden gems that go unexplored and unexploited. So the objective of this session is to introduce you to certain hidden techniques and hidden gems of Kubectl that actually make us more productive. In that process, I'm also going to introduce certain capabilities of Kubernetes that are only available through Kubectl. So, as I mentioned, this session is slightly different. I don't have many slides. In fact, this is the only slide. And the very next slide is the demo slide. So, let me switch to the demo and show you what I have here. So, I have a very simple Kubernetes deployment. So, I have CoreOS based Kubernetes deployment running one master and two nodes. I also have a very simple web application deployed. So when I actually do get pods, I have a couple of web pods running, and I have a database based on MongoDB. And there are a couple of services. So when I actually say Kubectl get services, you will notice that I have the DB service, which is a cluster IP meant to be internal only. And then I have a web service, which is supposed to be accessible through the external node port. So accessing this actually gives us the web page. So this is basically a very simple to-do application. So we have very simple application that deals with creating a to-do application. So it's a Node.js based application, and in fact, I have walked you through the process of building and deploying this in one of my previous webinars. So that's the simple deployment, and then we are going to use Kubectl to basically manage this application and manage the whole cluster. So I have a set of commands that I want to start showing you. So most of us are familiar with this command, which is get nodes. You can also find out which pod is assigned to which node by running this command that says Kubectl Kubectl get pods -o wide. And this is going to be pretty interesting because it not only shows us the pod details, but it also points us to the node on which the pod is deployed. This is pretty cool. I mean, this is standard stuff. Pods get assigned to nodes, and when you actually scale a replica set, the number of pods are going to be distributed across the available nodes. So that is going to be pretty straightforward. But there are some scenarios where you may want to actually upgrade a specific node or fix an issue with a node. Let's say one of the nodes has a problem and you want to quickly fix it, but it's a part of the live cluster. There are a lot of deployments that are going on, and there are a set of pods that are already scheduled on that specific node. So let's go ahead and emulate this. So what I'm going to do now is to scale my replica set to 5. So when I actually do this and execute the get pods, so you'll actually notice that in a few minutes, we'll actually have multiple pods that are running on both the nodes. So 201 is my node 1, and 202 represents my second node. So obviously, the pods are distributed across all these nodes. And now I actually want to go ahead and upgrade my first node. So I want to make sure that I cordon this node. Now, why do I need to cordon? Because I want to move the pods that are running on this node to another healthy node and completely take this off from my cluster. But even before that, I want to make sure that no other pods are going to be scheduled on this node because the pods could be running using the horizontal pod auto scaling, or a developer might be deploying new pods. So the first thing that I want to do is disable scheduling on this, and that process is called cordoning. So the command that I want to show you, which I'm very sure most of us are not familiar with, because I discovered it just a few weeks ago and I was blown away by how powerful this is. So when we actually run this command called kubectl cordon followed by the node name, what this is going to do is it's going to take this node and detach it from the live cluster. Detach it as in it basically disables scheduling. So when you actually type kubectl get nodes, you'll notice that the scheduling is disabled on this node. So now what is interesting is when we come back and execute the get pods command, you'll notice that there are still some pods that are running on 201, the node ending with the IP address of 201. That's because we have disabled scheduling of further pods, but we haven't really moved away the pods that are already running on this node. So, but if I actually go ahead and scale my pods, let's actually go ahead and scale the replica set to 10. Now this is going to take a while, but when I come back and execute this command, what will be interesting is none of the new pods will be assigned to the node that has the IP address ending with 201. That's because we have cordoned it off, and we will not have any more new pods assigned to that node. So there we go. Now you'll notice that obviously all the new pods that are created as a part of the replica set scale operation have been scheduled only on node 2 with the IP address ending with 202. And this is a very, very powerful utility because we have been able to logically detach or disconnect one of the running nodes from the cluster, and no further scheduling will take place on this. So now what we can actually do is uncordon this node. So now I'm running a command called kubectl uncordon. So kubectl uncordon will bring back the scheduling power to the node. And what it basically does is, let's actually type kubectl get nodes, and let's make a node of this. Scheduling is disabled on node 1. So what we're going to do now is to uncordon this guy. So okay, so let me grab this command and execute this. So now we have uncordoned, and when we actually do get nodes, scheduling disabled is gone. That's because we have brought it back to life, and now any additional pods will get scheduled on this node. So now let's go ahead and scale the replica set to 20. And as this operation takes place, we'll actually notice that the pods are going to be deployed on the node that has been uncordoned, and very soon we'll actually notice that all these running pods have been successfully scheduled and placed on the uncordoned node. So let's just give it a couple of minutes and we should be able to notice that it is, there we go. So now we'll actually notice that there are multiple pods that are scheduled on the first node ending with 201, and that's because we have just uncordoned and it has come back to life. So this is actually a pretty good concept where you want to disable scheduling for a while, go to the node, fix some issues, and then start scheduling the pods again. But going back to one of my very first use case, what happens if you encounter a hardware issue with one of the nodes, or a software issue? You want to actually patch one of the nodes, and you don't want to have any pods running on that. So at this point, we have a few pods that are getting terminated because I have reset the number of replicas to 5. So let's wait for this to settle down. This is going to bring down the number of pods to just 5. And after that, I want to introduce you to the concept of node draining. So what node draining does is it will evict the pods from one of the nodes that we are going to drain and move them gracefully to another node. So the number of pods in the replica set still continue to be what we defined through the scale operation, but Kubernetes will gracefully move them from one node which is being drained to another. So drain is slightly more powerful than Cordon, because Cordon will only disable scheduling and it will continue to run existing pods on the node, but draining will literally evict. Sometimes it might actually kick out the running pods to another node by completely shutting them down and launching them again. But the idea is, after the drain operation, you'll have 0 pods running on the node that has been drained. So let's come back and look at the pods. So now we have a few pods that are running, and when we actually look at wide, you'll notice that 201 is running multiple pods, right? So there are at least 2 pods that are currently running on 201 from the replica set. So now what I'm going to do is to forcefully drain the node. So -- force is required, because this will actually force even if the policy is not enforced. So once we execute this, it is deleting the pods not managed by the replication controller. So if you have pods that are running on this node which are not a part of the replication controller or replica set, they'll be dead. They will not be relocated to any other node. But if you are running anything as a part of the actual replica set, they'll be gracefully moved to another node. So very soon we'll actually see that the pods are going to be evicted and the node is drained. So now let's first check the number of pods. So now you'll actually notice that DB pod is gone. That's because it's not a part of the replica set, but all other pods which are part of the replica set have been successfully moved to 202. That's because the drain operation will ensure that the replica set definition is respected, and it ensures that even if the node is completely drained, it will relocate the pods from this node to another healthy node. Now technically this is basically cordoning off a node and also evicting the pods. So draining is a combination of these 2 operations. First, cordon off, so disable scheduling, and second, kill any pods and make sure that if the pod is a part of a replica set, gracefully move them over to another pod to maintain the count. Since the database is not a part of a controller, that is a replica set or a daemon or a job or a replication controller, it is dead. It has gone down along with the node that we have drained. So now when we actually do a kubectl get nodes, you'll notice that the first node is back to scheduling disabled tag. That's because drain operation literally cordons off the node. Now how do we bring it back? Well, pretty simple. We are now going to uncordon the node. Uncordon will bring it back, and now the node is uncordoned. When we execute get nodes, this is back. But interestingly, the DB pod is not going to show up because it is not a part of the replica set. So it's time for me to actually create the DB pod, because it was killed as a part of the drain process, and this will ensure we have the DB pod. And I also had a web pod that has gone down with the drained node. So let me also bring it back, because we need that. Oops, kubectl create -f followed by the web pod. Okay, so now we are back in action. So we are back to where we were. So now when we actually do, where is my web pod? Okay, so it should show up. So now we are back in action. So kubectl get pods, kubectl get nodes will actually show us that we have 2 nodes that are active. Scheduling is enabled, so any new operation will continue to work on this. So that was the quick demo. So let me clean it up and then reset everything. So I also want to show you this trick. You can actually use -f and pass the parameters. For example, I want to get rid of my db pod, web pod, as well as the web replica set that I have. So this is going to delete all the pods and bring back my deployment to a blank slate. Okay, so everything is now terminating. So I want to summarize what we have seen so far. So first we looked at cordoning of node, which is nothing but disabling the scheduling, but the pods will continue to run on the cordoned off node. Then we looked at draining the node. Draining literally takes the pod, relocates it to another node if it is a part of the replica set. Otherwise, the pod will basically die. So that was a part of the draining process. All right. So now we should be okay. So now I'm going to create my resources all over again because I want to show you the next demo, which involves creation of these resources. So let me go ahead and create a web pod, a standalone pod, and then another replica set, which is a part of the deployment. Okay, so now we should be back in action. Perfect. So now we have everything reset. So the demo is back. And now we are going to see some interesting mechanisms. Okay, so I want to introduce you to a command called kubectl get pods with a switch called watch only. So let's actually split the screen into two. Okay, so I'm going to use the nifty tool here, which is split horizontally with current profile. So I'm going to execute this command, which is kubectl get pods watch only. So this is going to be in a standby mode, and it will report any changes that we make to pods. The watch only switch is an indication to kubectl to only figure out when there is a significant change to a pod lifecycle. That means container creation to running to terminating or restarting. So any of those events will get reported and will be shown with kubectl get pods. Now at this point, there is no ongoing operation. So that's the reason why this part of the window is blank. So let's go ahead and actually scale the replica set to 20. And then we should be able to see a bunch of activity here, right? So here you'll actually notice that the scale operation has resulted in creation of 20 pods, and that is showing up here. So if we actually keep staring at this, you'll notice that the same pod goes through pending to container creating to running, and in just a few seconds all the pods will move into the running state, after which again the kubectl get pods watch only will move into a standby mode. So that's the interesting part of this command. So if you really want to know what is going on with your pod lifecycle, this is the best command for you to execute. So once everything comes to running, you can verify. There we go. So there is an error with one of the pods, and that may be reset. So the restart event also becomes visible here. So let's go ahead and execute kubectl get pods here, and now everything is in running mode. Fantastic. So this is exactly what I wanted to show you with the switch called watch only. So this is a very nifty utility when you want to track the life cycle of the pods. So let's go ahead and reset the replica set to 5. And again, our window here will start showing us the terminating status, because 15 of the running pods are going to be terminated. And that's why we are actually seeing terminating. And very soon, all of them will vanish. And next time when we actually execute kubectl get pods here, you'll only have 5 or 6 of them running. So that's the idea of kubectl watch only. Kubectl get pods watch only. So that was a very quick introduction to watch only, and you're actually noticing that there is a lot of activity and everything should be now reset, and there we go. So now we have exactly 5 web pods based on what we created earlier. So now what I want to do is get rid of my replica set because I just need one pod. So I'm going to delete. Okay, I need to be in the right folder. So cd demo /app kubectl delete -f web replica set. So this is going to delete the replica set, and along with it, all my web pods will be gone. So now we are running just the DB pod. So to bring back my okay, so now I'm going to bring back my standalone pod, which is not a part of the replica set. So now at this point, I have exactly one DB pod running and one web pod. And here the status has moved to running. So very soon everything will be cleaned up and we'll be just left with one DB pod and one web pod. All right, let me also get rid of this window. We don't need it anymore. All right, so now I want to show you a very cool utility, right? Typically, when you have a set of pods that need to be accessed from the outside world, what do? We expose them as a service. For example, here I have two services. One is the DB service and the web service. Okay, so kubectl get services will show us that we have a DB service which is exposing MongoDB on the default port, and then we have a web service that is exposing it on port 32665. So that's what was visible when we actually ran it here, right? So this is my web application. Now, what if you want to access the web server without exposing it to the outside world, right? So I don't want to create a node port service. So I actually want to get rid of the web service, right? So now we don't have the web service running here, right? But I want to quickly access the web page that is actually running. So now when I access, because this port is gone, I can't obviously access my web application. But if you have a pod that is exposing a port, you can use a very simple tool, which is called kubectl port forward, followed by the pod name and the port that you want to expose. So now we are bypassing the creation of a service and we are directly exposing the pod that is available on port 3000. So now when I actually execute this, the pod is now available on this port. Guess what? Now when I come back to the browser and type localhost 3000, we get to access the web page. And now the beauty is we are not talking to a node port service. We are directly talking to the Node.js server running inside the pod and inside the container. So this is a great mechanism for you to debug web applications without going through the process of creating a service, because most of the times you want to debug your web application running inside a pod and you don't want to go through the hassles of exposing it as a service or a load balancer and so on. So the moment you launch a pod, you can immediately run kubectl port forward and expose it on a specific port, which will become available on localhost. It's a brilliant mechanism to debug front-end web pods or front-end pods that is exposing a specific port. So again, I discovered this recently and I find it to be extremely powerful. So hitting Control-C will terminate and you can get back your service back in action. And now our service is available to the outside world, not just the local host with the node port. So this is the node port and we can actually hit the portal from the browser. So now we are accessing the same web application, but from the node port. So that's a very powerful concept. Now, the other thing that I want to show you is a mechanism to actually copy some files from the host machine to a pod, right? How many times you have felt that you need a static file like a CSS file or a JPEG or a configuration file that you want to quickly move from your local host to your pod, because if you're running a Docker image, it's pretty straightforward. You can mount the host volume inside the Docker container. But if you're running a pod, it is not that straightforward. You have to first define a volume, and then if you're running it inside Minikube, or if you're running it inside another VM, your Mac or your underlying machine may not be easily available to the pod. So if you want to quickly copy a file from your local host to the pod, there is a command called kubectl cp. So let's actually try that. So now I'm going to use kubectl exec to access the shell inside the Node.js container. So this will drop me right into the Node.js container packaged in the web pod, and we are inside user source app directory. And because I'm using the Express framework, most of the static content is available inside this directory called public. And currently, we don't have any HTML file here. There is a favorite icon. There are a bunch of style sheets and JavaScripts and images, but we actually don't have a HTML file. So let's actually go through a process of copying a HTML file from the host to the pod. So let me move to the demo directory inside the app directory, and here I have a very simple file called test.html. It does nothing but printing copied from host, right? Very simple. Now, when I hit test.html in the browser, Express will throw an error saying cannot get test.html. Now, what we're going to do is use the kubectl cp command to actually copy test.html from the local host to the pod. So the command is pretty straightforward: kubectl cp source, which is my current directory, test.html, followed by the pod name, which is web, and the destination directory. And once I execute this, it is successfully copied. We can come back to the pod, execute ls, and guess what? Test.html is right here. And if you're still not convinced, you can come back, do a refresh, and there we go, right? This is again a very, very powerful tool for web developers targeting Kubernetes, because without going through the process of mounting volumes and exposing the host-based file system, you can very quickly copy file from the host. That's not all. You can actually copy a file from the pod to the host. All you got to do is change the source and destination. So instead of the source being the local file, you can actually swap, and you can very easily copy content from a pod to your local host. Again, a very, very powerful utility, which typically goes unnoticed because it's not one of the well-known popular commands of kubectl. So that was copying files from host. Now, switching gears, I want to show you a mechanism where you can learn about the shortcuts of Kubernetes objects. For example, instead of typing kubectl get pods, do you know that you can actually type get po, and it's going to execute the same command? Similarly, instead of typing kubectl get services, which is pretty long, you can type get svc. So this is again a very handy mechanism of accessing Kubernetes objects, and every object of Kubernetes has a shortcut or an alias. But again, it's very difficult to access it when you really need it. So there is a command which is called kubectl explain, and what this is going to do is going to show us the alias, the shortcut, and the short names of all the Kubernetes objects printed here with, and also known as alias. So if you want to access certificate signing request CSR, look at how productive this is going to make you. So instead of typing this lengthy one, you can just type CSR. And similarly, if you want to access more frequent objects like pods, you can actually use PO instead of pods. And of course, replica set is known as RS. Replication controller is also known as RC, and services are SVC. So basically, you can use this command to quickly find out what is the alias and what is the short name of a specific object. For example, horizontal pod autoscaler is too long to type. So instead you can actually use HPA. So kubectl get HPA. So it's a very handy utility for you when you are dealing with the Kubernetes objects. All right, so I also want to show you some additional commands. For example, when you type kubectl get pod web, it shows the current status, but you can also print the actual YAML definition of this pod. So when you say -o and the output is going to be in YAML format, this is going to print the YAML definition of the pod. So if you want to learn how to create a pod, or if you want to reverse engineer a running pod, the best command to execute is -o is equal to YAML. And this is going to show you the YAML definition of a running pod. For example, it is currently using an image, which is Janakiram m/todo. It talks about the container port. This is essentially the YAML definition of my pod, but this is more elaborate and more formal because this is how Kubernetes ultimately sees the pod object. If you don't like YAML, if you're a JSON guy, you can also type -o JSON, and guess what? This is now going to print a JSON definition of the pod. Again, you can redirect this to, for example, webpod.json, and then you can open this in your favorite editor. And there we have the entire definition. So this is again phenomenal tool for reverse engineering what you already have. So, and this is also a great mechanism for you to learn how a pod has been packaged and how it is defined, even if you don't own the pod. And this is how I'm learning a lot of insider mechanisms of packaging and deploying a pod. Again, a very handy utility. The other thing is, if you want to access the container in a pod, because a pod can contain multiple containers, right? And knowing which container is currently packaged as a pod is not easy. So one of the commands that I want to introduce is kubectl get pods followed by the pod name, and then giving the output as the JSON path. For example, .spec.containers-name. So now this is going to print what is the container name running inside the pod. And if you're wondering where is this coming from, this is actually a part of the JSON spec that we have just explored. So now if you actually open webpod.json, and if you look at within spec, there is containers and there is name. So whatever you want to print, you just need to replace the JSON path with that. For example, if you want to print what is the port that this pod is listening on, it will be obviously spec.containers, and within that you can mention, I'm taking a risk of trying something live. So the first container, and then we are going to type ports, the very first port, and we are going to print the container port, and there we go. So this is again a very handy mechanism to explore the insider information of a container packaged as a pod. I hope you are finding this useful, because most of them are undocumented, and even if they are documented, they are buried somewhere inside the large collection of Kubernetes docs. So I'm going to make this entire file available to you. In fact, I'm going to write a detailed article on unleashing kubectl on the new stack. And in a couple of days, this article should go live, and you can basically try all these commands. All right, so that was listing containers in a pod. If you want to sort the running pods by name, you can actually execute this command, which is sort by metadata name. And as you notice, it is going to be sorted by name. You can actually pick any of these metadata information and sort the output based on that column. So that was another simple utility. And if you want to really print a very short formatting where you want the pod name and the node on which it is running, I am now using the awk command, the ever powerful, ever sexy command of awk, and I'm actually using it to print the first column and the 7th column. So now this is going to show us what is the pod name and what is the node that it's assigned to. So again, this is a combination of the standard evergreen awk command with kubectl. That's not all. You can not only reverse engineer by printing the YAML or the JSON definition, you can edit. So for example, if you want to edit the web.yaml file and quickly submit it to Kubernetes, you can type kubectl edit followed by the object that you are accessing. Because we are using the pod object, I type pod / the pod name, which is web, and this is going to open the entire YAML definition inside the Vim editor, because that is the default one. So you can get out of Vim, and I'm typically a Microsoft guy, so I struggle like most of you to use Vim. So it is definitely not my favorite editor. So if you want to open this in your favorite editor, you can use a command line variable called Kubectl and give the favorite editor name. For example, Sublime is my favorite editor, and then continue with kubectl edit. So when you actually use this, guess what? It opens this straight away in Sublime editor. You can replace this with VS Code or any of your favorite editors, and kubectl will end up opening the definition in one of these files. So when you actually save it, it is going to be impacted immediately. So this is a live modification of your Kubernetes objects. You can do this with any service. For example, any object. For example, here I can say service web, and this is now opening the definition of my Kubernetes web service. So now you can actually modify the node port or whatever parameter you want to change, save it, and it's going to be impacted immediately. Again, a very interactive mechanism to take control of running Kubernetes objects. One of the last sections that I want to talk about is the other powerful tool called kubectl proxy. And kubectl proxy will simply open a tunnel into Kubernetes cluster. So you can mention the port. I have a conflict with the default port, so I'm currently using port 8000. So when you actually hit enter, now the Kubernetes cluster is available on the local host at port 8000. And after that, you can start exploring a lot of things. For example, if you want to access the Kubernetes dashboard, you can always do that with this command, kubectl proxy followed by opening a local host, the port /UI. And now here we have the powerful Kubernetes dashboard. So you can now access the dashboard. It shows a lot of information, and this is how you can access the GUI of Kubernetes. All right, that's not all. If you want to perform some operations from the command line, nothing stops you from using your favorite curl command. So now when you use curl http localhost port 8000/API, it comes back and tells you what is the API server location. So currently the API server is listening on the master, and it is a TLS protected port. So that's the reason why it is 443. The client CDR is basically all the IP addresses. So this is where the API is available. I can go one step further and actually use this command, which will print the list of nodes. So again, a curl command with the get request to the nodes. So now you have a pretty long listing of the metadata. And if you want to be crisp in the output that you see, you can use a tool called JQ. JQ is available on Linux and Unix machines, including macOS. You can actually use brew install JQ, and it's going to give you this nice tool called JQ, which is a command line parser for JSON. So we can now pipe the output of the curl command into JQ and print exactly what we want. So now this command will show us more useful information by filtering out the metadata that is not very useful. So it tells us what is the operating system, what is the host name, and if there is any other metadata that's going to show up here as well. So, and I'm not using the kubectl command. Instead, I'm actually retrieving the API and piping it through JQ to filter what I want. You can also find out what are the APIs running on the node on your cluster. So with kubectl API versions, it basically tells you what is supported in your cluster. V1 is production ready, storage is in beta, and there are some very early features like the policies, the authentication, authorization, all of them are in beta, but some of them have moved to V1. For example, auto scaling is V1. So you can actually find out what are the APIs exposed by your cluster and what is the version of each API. Typically, certain production clusters will block the beta and alpha features, so you cannot use them. So if you want to really find out what are the supported API endpoints and API versions, you can always use this command. So a combination of these two, for example, a curl command to the API endpoint followed by the API versions will precisely tell you what your cluster is capable of. So you can now start using those objects or making calls to one of these specific APIs. So again, a very powerful one. Finally, I want to show you how you can use the power of API to create additional objects. So now I have a very simple Nginx pod and a service definition here. And what I want to do is extend the curl command to actually create a Kubernetes objects. So I'm going to create an Nginx pod and an Nginx service, not using kubectl, but using curl. So how do I do that? Well, let's first make sure we just have these two pods, DB and web. One is MongoDB, the other one is Node.js. And now I want to launch a pod that is running Nginx. So I'm going to use this command, which is curl followed by the endpoint, which is API v1 default namespace pods, and I'm doing a post by passing the local file name. And I'm filtering the output just to get the status. So this curl command will pick up the local Nginx pod.json, and it does a post to the Kubernetes cluster endpoint. So now, of course, this is pending because we just started creating the pod. So when you actually get the pods, you'll notice that Nginx is now running. And I didn't use kubectl. Instead, I used the curl command. So this is, again, very programmable. If you are using, let's say, an Android app or an iOS app, or you want to build a custom UI to create pods, you can actually use the same API, not from curl, but from your custom application. So that's not all. You can also create services. So now we have just a couple of services, the DB service and the web service. Let's actually go ahead and create the Nginx service. So I use the similar command. This time I am pointing the endpoint to /services, and I'm doing a post. So this is going to come back to us with the cluster IP, because that's where the service is going to listen. So kubectl get services will now show us that the Nginx service is available within the cluster. So again, a very programmable way of creating pods and services. That's not all. You can actually delete. So let's go ahead and delete the service, again by passing the endpoint and the actual service name and using the delete verb of the HTTP protocol. So now we have successfully deleted the Nginx service. So kubectl get service doesn't show Nginx anymore because we used curl to get rid of it. And we can also use the same command to get rid of the pod. So now I'm actually deleting the Nginx pod. So when I execute kubectl get pods, Nginx is gone. So again, this is not exactly kubectl, but a pretty powerful mechanism of using API to deal with Kubernetes operations. So that brings us to the end of this session. As I mentioned, this is going to be a very demo-driven session, and we have gone past the time by 15 minutes. So I see there are some questions. So before I take the questions, let me take you back to the slide and announce the next webinar for July. So I'm very excited to bring you everything that you want to know about ingress controller. So ingress is a mechanism to expose services, but not using the typical cluster IP or node port. This is becoming very popular among Kubernetes users, particularly running in production, because it lets you use a custom load balancer or a custom router to access your web applications. So we are going to build on the concepts of services. We are already familiar with cluster IP, node port, and load balancer. So I'm going to build upon those concepts to introduce what is an ingress controller, what can it do, and how is it comparable to existing services endpoints. And we'll also look at some use cases. So I'm going to actually set up ingress on GKE using the standard HTTP load balancer of Google Cloud Platform. So that's the session on July 12th, Wednesday at 9 a.m. PST. We'll be updating cube.live page in a day or two, and you will receive a mail to register. And I look forward to seeing you for that webinar as well. So let me look at the questions. Okay, so there is a question on how do we prevent Kubernetes to create a pod on certain host. There is a concept called node affinity. So the best mechanism for you to either prefer a node or to avoid a node is to have the node label and selector. So basically you got to tag every node with a label, and when you're creating a pod, you got to introduce a policy called node affinity and point that to either a specific node using the label, or you can also negate it if you're using annotations. So it is not exactly a kubectl command or a switch, but it is more to do with your pod definition, because it has to be a declarative policy at the pod level and not exactly at the kubectl level. So there is a request to share the file with all the commands. Absolutely, not just the file, but the entire explanation of what I have done. So the entire transcript of this webinar as an article is going to be available at the news stack in a couple of weeks. I'll update the YouTube link with the YouTube video with the link to the article. So I know we are past the stipulated time, so thanks once again for attending this webinar, and thanks for encouraging us by coming back to attend cube.live series. And we are committed to bringing you the best of the Kubernetes content in the upcoming webinars. Thank you and have a great weekend ahead.